In this demo, we will be looking at the second version of the upload utility. The second version is improved by allowing the client to choose any file that they want to upload. We use readLine.question to prompt the user for the file that they want to enter. So this will receive the line that they type in. And if they type in !quit, we will exit the program. Over here, we run a function fs.accessSync to try to test to see if this file exists. And if it doesn't exist, we will throw a error, which will catch. And then we will use io.question again to prompt them to give us another file choice or a quit command. So eventually we will get a valid file. And so we're going to open that file using a read stream. And what we're going to send this time, because we have to work with arbitrary files, the server does not know the file name at this point. So before we transmitted the length of the file, because we know that the server doesn't know the length of it, so it doesn't know when to stop. But in addition, we're going to include the file name this time. So this changes our diagram somewhat. So before this was just length, because the server knew the file name from beforehand because there was only one choice, which was small.dummy. Now because we can send any arbitrary file, we need to not just send the length, we also need to send the file name. And again, we're just going to pack this into a single string and assume that that one chunk reaches the server. And again, this is not something that we can assume every time, but the only way to solve it is to have a header value, and that's going to sort of make this code much, much larger. So we're just going to continue to assume that there's only one chunk. We extract the file stream, file name, and length. So to extract the file name, we use a built-in library path, which allows us to get information about files, including the base name. We use fs.stats to pull out the length value, and then we send these three values to our connect function, which will create the connection. And then once the connection is created, the connect event fires, and the connect event will send the length and the file name separated by a bar character to the server. The server is going to receive this chunk. Again, our assumption is that it's a single chunk. It's going to split it on that bar symbol. The first component is going to be the length, represented as a string, and the second component is the file name. For the length value, I want to convert it to a number immediately so that I don't have to worry about it. So now we have the total length of the file as well as the file name that we're trying to upload. So we're going to create a writable stream using that file name. Okay, so that's going to be in our output path. Then we're going to set up a listener that's going to call the function receive data every time we receive the next chunk. Previously, this was called receive length. Now it's called receive file info because we have the added file information. This only gets called once, and then it sets up a data listener for receiving the actual data. This function also had some minor changes, in that because now I'm expecting very large files, I wanted to print the progress all on the same line. So before it printed printed this message new chunk followed by the size of the chunk and the percentage completion onto a new line, and now it just moves it back to the previous line. Okay, so we're going to run the program next. So let's start our server. And so inside of our input directory, we have a small.dummy file, which we can upload to our output directory. And let's do that first. So let's upload the directory is /input/small.dummy. And so I would focus on the server progress right now. Okay, so we're going to see that that's almost instantaneously because this is a really tiny file. It's only 512 kilobytes. So essentially the progress, even though it essentially it's supposed to update on each progress. Before we saw that there was sort of 5 chunks. Those 5 chunks happen so fast that it's not really visible. To combat that, we're going to use a larger file. Okay, so in fact we do have a larger file, which is the one that we used in the streams example, which is create 1 GB file.js. So I'm going to run that, and that is going to take a while, but it's going to create a very large file inside of our input directory. And then we are going to upload this file to our output directory. Before we do that, let's look at Wireshark to see how many segments it took to send the 512 kilobyte file. So we have roughly 39 segments to complete it all. In fact, let's reset this and see how many it takes to send a 1 GB file. So this is going to be substantially more because, well, the data is larger, but also when we get to sort of sending data of that threshold, buffers get exhausted and segments start to get lost. So retransmission has to occur. This is not something that we on the application layer care about, but it will happen. Let's clear this, and we're going to run the client. And the file that we're going to upload is input/1gb.dummy. Okay, so now we can actually see the progress, and this is still really fast just because it's communicating with the exact same computer. The only thing that's sort of slowing me down is my own disk speed. But let's look at the Wireshark output. Okay, so you can sort of see that there's tons of stuff that are sort of lost. To send this 1 GB file, it took 8,407 segments.